So hello, my name is Artur Ashlajus, if you don't know me, but you should probably know me. I come here occasionally to talk about Scala, which is technically a JVM language, and this is a JVM user group. Therefore, I'm here. And today I'm going to talk about introduction to full stack web development with Scala. And of course, the first question is like, why Scala? Why would you do this? And Scala is very concise and very expressive language. And that's nice, but probably the biggest thing that I like about Scala is the compile time safety. So with Scala, the whole ecosystem, everything, everybody is writing code in a way that if it compiles, it will run, and it will most likely run correctly. And it's sane compared to things like, for example, TypeScript. And this is anecdotal evidence, but with TypeScript, I've read this, we're going to compare 5 libraries that do big number calculations on TypeScript, and 3 of them are disqualified because they do the wrong math, right? So if you do full stack web development with TypeScript, which a lot of people do, you have this problem of an ecosystem which isn't really known for its quality. So Scala has very great ecosystem where you can does what it says on the tin and does it correctly. Additionally, Scala has great JavaScript/TypeScript interoperability, which is like when I started looking for tools for my new venture, I looked at Scala, C#, Java, Kotlin, Rust. And for example, Kotlin does have a JavaScript backend, but the problem is that the type system of Kotlin isn't expressive enough to map the things that exist in TypeScript and JavaScript world. For example, Kotlin does not have any type unions. So there's a problem there. Scala does have type unions. I already covered the great ecosystem part. So, full stack, what does it mean? So for the backend side of the stack, we do have, Scala has a bunch of variants. So the original one and the most developed one is the JVM one. Scala used to have a CLR one, the .NET Common Language Runtime, but that has been dropped. We also have an option to, as with any JVM app, run as GraalVM native image. Why I listed it as a separate thing is because, if you take a Java application, so there's things like Quarkus, which are kinda oriented towards the native image part of it, but usually Java relies on a lot of reflection. And reflection and ahead of time compilation isn't really fun to do, at the same time. So Scala being a language that has great compile time capabilities pretty much doesn't use reflection. And it's a very easy experience to make a native image. Usually it's just, you drop a line, and if you use full Scala stack, which you should, it just makes a native binary. Scala also compiles to JavaScript, obviously, so you can, in theory, run your backend on Node. I'm not sure, you can use it, for example, in serverless settings, because that starts up very quickly. Scala also has a native backend, which is compiled against LLVM. It's out of experimental, out of alpha. It's I don't know, I wouldn't use it, but it's there if you want for some reason, but you do have JVM. Maybe for serverless stuff, the performance will be lower than the JVM because JVM is great. And additionally, we also have, Scala has recently landed alpha level support of WebAssembly. So you can run it in the backend as a WebAssembly module and run that instead of, in a WebAssembly engine instead of Docker. And for the front end, you have the JavaScript and you have the WebAssembly as well. And, the shared code. So let's start from the front end. What do we have there? And we have a bunch of libraries there. You don't have to rely on, JavaScript things. So we have native Scala JS libraries. We do have a couple of libraries for the reactive style. We have a couple of libraries, well, for the virtual DOM style. I didn't list all of them. We do have a couple of React wrappers if you can't live without React. But I would say that you should live without React, and React isn't really fun and great. We do have like HTMX-like libraries. So Korolev is an interesting library where you basically write code and it does the whole, dance of thin client, here the server, and the sending of HTML automatically. And more, which is a link to like a list of a bunch of approaches that people have built with Scala.js, which is also a thing. For example, when I looked into Kotlin, it doesn't have as many front-end libraries. It has like 2, I think. So let's go through over some of these and just kind of have an overview. So Laminar, this is my favorite one. I'm using this. It has a very simple mental model. It has great documentation. It has a text documentation. It has some videos. It's extremely fast because it doesn't do any virtual DOM. It doesn't do any diffing. It's just, you change something, it propagates it through the reactive values and just changes the exact property that you need. With React, there's always a problem of how do we manage state? Do we use Redux? Do we use something else? So with Laminar, that's very simple. The downside of it is there's no single page application support yet. So Laminar doesn't really run in server side. It's only Scala.js application library. So it's not published for the JVM part of it. There is like a way to make it do that, but it requires development, and this is open source, so you can either do it yourself or you can sponsor it to make it happen. So if you need single page servers, I wrote SPA. This should be server-side rendering, not SPA. Yeah, so this should be server-side rendering. Anyway, so this is an example. In Laminar, you do have here's a variable, and variable is basically a mutable box which will propagate and tell others about the changes of it, and then you create some HTML with this syntax, which isn't HTML, but very similar. And you say when the input happens, let's put that input thing into this variable, and when the variable changes, let's turn that into the uppercase and put that into the text of this paragraph. So in Laminar, basically you have 4 things. You have variables, which are mutable. You have signals, which always hold a value but are read-only. And then you have the same things for the event streams. You have an event bus where you can push events, and then you have the read-only side of it, which is called event stream. There's a very similar, functionally library called Calico, and there's this type level ecosystem, which is for pure functional programming. So if you're into that, you can switch out Laminar to Calico. It's not as developed as Laminar, doesn't have as many docs, but essentially they're very simple libraries. Fundamentally, they don't really have to do very much. So if you take a look, it's very, very similar. So instead of var, we have a signal and graph. We also give it a thing. Then we say, hey, every time this name changes, do this thing. You can read the docs. There's also Tyrian, which is if you like virtual DOM style, there's Tyrian, which is Elm-inspired, purely functional, and I wrote SSR correctly here. So yeah, it will look a bit different, and it looks more similar to what you would expect from React. So basically you have to say, hey, there's an application and there's two parameters for the application. So one is a model, and this basically says like, this is the application state. And in our case, the application state is just a string. And then there's messages, like an action. And an action is basically, there's either gonna be new content or no action will happen. And then you have a view which will create the virtual DOM here. And when you change something, you say, okay, on this event, there's gonna be a new message that will say, here's the new content. And what happens is Tyrian will dispatch that into this update thing, and it will say, here's the model, right? And you get a message, and you say, if the message is this, then return this new model and like do a command. And commands are basically like send a network request or some other side effectful things. So this model is like exactly the same one that's used in the Elm language, and Tyrian just replicates it on Scala.js. I did not cover the rest of the libraries. You can always like read the documentation yourself. So TypeScript interoperability. TypeScript is, well, it exists. It's a pretty nice addition compared to JavaScript to our lives. And the great thing about TypeScript is you actually get types. And it's very nice to use those types from Scala. So I'm using the build tool. So you just basically add a plugin for that. And then you define like a module that says, hey, here's my Node.js packages thing. It's there. And here's like the packages that you should ignore and not convert. And that's pretty much it. You run a build. It checks the packages that are installed with Node and with NPM. It looks at the types and converts all of that into Scala type definitions and attaches that to your project. So using that looks like this. It basically puts everything into this namespace typings, and Cytoscape is a library, a JavaScript library for rendering things. And TypeScript uses a lot of verbatim strings, so those become like Cytoscape strings. Like the globals could go into this package, like some other things go into module, and this is like CSS stuff and other types, etc., etc. But you can import that, and it's kind of annoying to do this. But hey, beats writing JavaScript facades by hand. But the usage is, pretty simple. You just, use it. It does some conversion between what is available in TypeScript and in Scala. So you sometimes have to use backticks to escape the method names, but otherwise, that's it. And this, for example, says set style, and like here's the JavaScript array that you should pass into the library. Yeah, some more things, and this is, for example, an example of using an untyped API. So on Cytoscape, this is basically a string, and this is a function with some very vaguely typed parameters because it accepts strings. So, you have to do like, hey, I have a target here, so let's do like as instance of and cast it to this thing JS dynamic, which basically means just fall back to dynamic typing. And then you can call ID, and that calls into ID on JavaScript, and you say this will be a string, and then you do the rest of the stuff in a typed way. Okay, shared code. So most of the Scala libraries, when somebody writes a library for Scala, he or she has to build it and publish it to Maven repositories. And you build a library, you have to build the library for the target platform, and you have to build it for the JVM, for Scala JS, or Scala native separately. So if somebody has a library and technically it would compile to Scala JS, but it wasn't published, you'll have to go there and update the build to actually build it onto Scala JS. Thankfully, that's usually quite easy, but like most, I would say 95% of the libraries that can run on Scala JS will have a Scala JS artifact published. Java libraries cannot be used and cannot be converted to JS. So it has to be on Scala stuff. And your own code, of course, can be shared between the JVM version and the JavaScript version. And probably the biggest thing is like, how do you define this code that talks between your client and the server? And for that, we have a library called tapir. Tapir, I don't know. Anyway, it's an endpoint definition library, and basically you just say, hey, there's going to be an endpoint. It's going to be like a post. It will have security inputs, and it will authenticate via a bearer token with this type, and it will look up in compile time how to actually decode that from the string. It can fail with this. It will be available at this route. It will have this JSON body. It will output this, it will respond with the status code, and it will return this JSON body. And you have a definition of an endpoint. Now, what do you do with that definition is, in the server side, you need to turn that into an actual route that is executable. So, for example, here I'm using this library HTTP4S, which is a functional programming HTTP server. And basically you say, here's the endpoint, and here's the security logic implementation, and here's the actual logic implementation, and turn that into a route, and then you just stick that into a router, and it runs. The authentication logic, for example, just looks like you get your data type, and then you return either an error or something that worked, and you do whatever logic you need here. The main logic is very similar. You just get the decoded input that Tapir does that for you, and you respond with something, and Tapir handles the serialization and sending it out. Tapir supports a bunch of HTTP servers. Did I list all of them? I'm not sure. But yeah, it supports like things like Vertex from Java. It supports Netty if you like that. It supports, there's like 30 things that it supports. And in client side, it's also like super easy. So I'm using this STTP client library in the Scala side, and you just say, hey, please turn this endpoint into a request. You give it a URL where your server is actually located. You give it the security parameters. You give it the actual parameters. And there's like a distinction between the security logic and the actual logic. I think like for logging reasons, and so you could know whether the request failed because you couldn't really authenticate, or because or if it failed because of logic reasons. And then you just send that, and you get back a response. Server. So I asked some people what they would like to know about this whole full stack development, and some people said, how do you read configuration on the server side? And with Scala, it's kind of interesting. So I don't know, with Java or Rails, usually people tend to gravitate to these frameworks where everything comes with batteries included, and you do things in the framework way or in a painful way. So Scala is usually more like build your own framework type of situation, where you have a bunch of libraries and you assemble them into your own mini framework that you like. So I mentioned 3 libraries here which I like. So Cirrus is a library that allows you to read configuration from the environment or from config files or from any other pluggable backend. But it's pretty simple. You have a type for your configuration, and then you define how do you want to read that. So you say, here's this you read these environment variables, you can provide defaults, and you can compose configs into larger configs by just listing them out and joining them together. There's also pure config. So there's this configuration format called Hocon, which is like a super powerful JSON with includes and comments and expressions and stuff like that, which is a great format for configuration. I recommend it to use it even in Java. But you can use pure config for that. The type-safe config library itself is implemented in Java, by the way. So it's a Java library. So this is how Hocon looks like. You have arrays, you have objects, stuff like that. And there's also this library called metaconfig. And this one is an interesting library because it has this goal of being able to evolve configuration without breaking changes. So for example, if you're building a public-facing command line tool, let's say, and then you release a new version and you want to rename a configuration parameter and you don't want to write the whole migration boilerplate, metaconfig works for that. And it also automatically gives you a command line argument parser from your configuration. So you could either read it from the file or you could provide it through command line. Database migrations. No surprises here. Everybody uses either Liquibase or Flyway. I prefer Flyway. There's a Flyway for Scala. Blah, 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 some code. It just, it's Flyway. Nothing special. Building. So as a build tool, I use Mill, but there's also the famous or infamous SBT, Scala build tool, simple build. I think it was called simple build tool until somebody realized it's not that simple and renamed it into Scala build tool. So Mill is a new contender on the block, and it's Java and Scala and Kotlin build tool, and I like it very much. It's very easy to configure. I like it much more than Gradle. I hate Gradle as well, by the way. And I've spent 8 years dealing with Gradle in Android setting. So you write Scala code, and it's a very simple object-oriented, standard Scala code. And Mill runs a server in the background automatically. So you launch it, it launches a daemon, and then it does things very fast. So basically, a normal development flow would be in one terminal, you run Vite, which is a JavaScript bundler, and you run a development server so that once you change your source code, it gets recompiled to JavaScript, and that gets picked up by Vite and sent to your browser, and voila, you have your changes there. And on the other terminal, you say, hey, Mill, please watch this project, and do the client side, and run the server in the background. Or you can do that in 2 separate terminals and have 3 terminals. One running the client side recompilation, another one the server side recompilation, another one with I guess the preference is with how many monitors you have to see the compilation errors. Deployment. So deployment isn't really anything special. You clean the Mill, you clean your code with Mill, because doing a clean recompile is always good, because Mill caches things which sometimes gets screwed up, and you do have to recompile, clean like the whole build cache and recompile things from scratch. Thankfully, it happens rarely, but it sucks if you would ship it to production. And then you basically run this universal stage and full. So this builds a directory with like your Java application, a launcher to launch it, which detects like the Java version and launches the main jar, etc., passes the arguments. And this builds a JavaScript bundle and runs it through an optimizer to make it small. And then you run that JavaScript bundle through Vita, which optimizes it further. And then I use this tool Kamal because I hate the cloud. And I think that €5 VPS is great and very cheap. And with Kamal, it's very easy. You say Kamal deploy, and that basically builds the Docker container. So you add a JDK, you add an Nginx, a supervisor, whatever you want. Copy the client for the Nginx to serve, copy the server, set up a health check, and launch it. And that's it. At least from my side. Now there should be questions or comments on how this all sucks. Yeah, go on.
Can you compare in terms of server resources? Let's take a single method API, get some random stuff, and as a Spring Boot application, we usually have this kind of application around a few hundred megabytes of RAM. What would it look like in Scala?
So the question is, like, if you take a minimal application, how much memory would it take, right? So it depends on what HTTP server implementation you're using. So for example, HTTPS doesn't really use Netty. They implement their own networking layer on top of the JDK networking APIs. So that should be very thin. But essentially you have the same problem that you have with JVM. It has to do just-in-time compilation and put the stuff somewhere. So I think that the least amount of memory that I reliably had a server on was something like 200, 300 megabytes of memory. But that was handling 4,000 requests per second. If memory is a concern for example, like auto-scaling applications, then recompiling the same application as JavaScript or Scala native could be an option, or Graal VM native image. Usually you do lose some performance from the ahead of time compilation because JVM is great at optimizing, but you gain that it doesn't have any start latency and just starts up instantly and uses a lot less memory.
And one more question. You were showing how to describe the API endpoint. Does it have any internal automatic Swagger generation?
Oh yeah. This is where I messed up and a part of my slides went away. Yes, it does have these documentation interpreters. So right now it supports Swagger, OpenAPI, and JSON schema. And you can add annotations on your data types to help it describe things for that documentation. You can also write out these schemas manually if you wish so. But yeah, the idea is that you write it and boom.
More questions? So thank you, Arturas.